we are going to learn how to solve the MCQs question that is based on more about the handshaking theorem and the type of graph. This is the second part of a video. Let's start with the first question. The first question we have, if we have any graph with vertices V, edges E, and that is an undirected graph with E edges and U vertices, then total number of edges is equal to what? As you can observe from the option, there is a mention as the degree of the vertices, and here we are taking the sum of degree of each vertex. Basically, this is a handshaking theorem. By the handshaking theorem, degree of graph is equal to 2 times of number of edges, and the degree of graph means we are taking the sum of degree of each vertex, or we can also express this as summation degree of each vertex u, where u belongs to the vertex set v, that is always is equal to 2 times of number of edges. According to this, option C is correct. Next is, a self loop in a graph adds how much to the sum of degree of all vertices? Means if we have any graph and any vertex contain a self loop, like in this case A vertex has a self loop, B and C does not have any self loop. The degree of the self loop is what? So degree of self loop is contributed as the twice. Although the count of number of edges as a self loop is 1, but it is contributed twice to the degree of the vertex. Like in this case, degree of the vertex A is 1 plus 1 plus 2, that is equal to 4. For B, degree is 2. For C, degree is 2. So whenever we have self loop, that is counted as the twice. So hence option B is correct. Next we have a graph with all vertices having an equal degree is known as what? Is it a multigraph? No, because multigraph states that it is an undirected graph in which multiple edges can be there. But there is no connection with the equal degree of the vertices. Whereas a simple graph, again that is about the no multiple edges, no self loop. It has no connection with the equal degree of the vertices. Regular graph. Regular means something is the same. Now what is that same? That is the degree of each vertex. So if the degree of each vertex is same, it means it is a regular graph. Hence option C is correct. Next we have a regular graph is that graph in which the number of vertices is odd in number. Is that is true? No, because it is not going to comment whether the number of vertices are even or odd. Regular graph simply means the degree of each vertex is same, and that is in our option D. So we have no restriction on the number of vertices, may be even, may be odd, may it contain the multiple edges or a self loop. Next is, which of the following is a degree sequence of K2, 3? K2, 3 means it is a bipartite graph and it is a complete. K stands for the complete, where C stands for the cycle, W for the wheel, and K stands for the complete graph. If we have simply K, it means simple complete graph. If we have two subscript form here, it means it is a complete bipartite graph. So here we have the complete bipartite graph K2, 3. Now we need to calculate the degree sequence. Before that, we need to take the degree of each vertex. Degree of this vertex is 3. This 3. Degree of these vertices is 2. Degree sequence means we need to write the sequence of the degrees in non-decreasing order. Means in the increasing format. Minimum degree is 2. How many times that is repeating? 3 times. After that, next degree is 3, that is 2 times. So this is the degree sequence of K23 graph, and hence by this option D is correct. Next, the number of edges in a graph with 10 vertices, each of degree 6. Now 10 vertices we have, degree of each vertex is 6. It means total degree of graph is 6 plus 6 plus 6 up to 10 times because we have 10 vertices. We can also write it as 6 into 10, that is the 60. Now total degree of the graph is equal to 2 times of number of edges by the handshaking theorem. So edges is equal to 60 by 2, that is equal to 30. Hence C option is correct. Next we have the statement. The chromatic number of three-dimensional cube is 3, and we have two reasons, reason 1 and reason 2. We need to identify whether the statement is correct and whether reason 1 or reason 2 is correct. Let's identify what is the statement we have. As per this, we need to find the chromatic number of three-dimensional cube. Three-dimensional cube means we need to deal with the Q3. Q3 is cube with 8 vertices and 12 edges. Now what is the chromatic number of this one? Chromatic number means no two vertices have a same color and we need to use the minimum number of colors. Suppose the color of this vertex is blue. It means these three vertices cannot be blue because that is adjacent to this blue color vertex. But we can assign this vertex as a blue color because they are not adjacent. Can we give any other vertex as a blue color? Yes, that is this as well as this. Now think for the other remaining four vertices, whether they are adjacent. No. Due to this, we can give same color to these four vertices as a yellow. Now the total number of color used in this case is 2. It means the chromatic number is not 3. Hence the statement is not correct. So option A is directly discarded because here it is mentioned statement is correct. Reason 1 is every complete bipartite graph has a chromatic number 3. This is completely incorrect because we have done this result. That is, bipartite graph chromatic number is always 2, not 3. Now, here the chromatic number is 2. It means it is a bipartite graph. Next reason is three-dimensional cube is a complete bipartite graph. As the chromatic number of cube is 2, it means it is a bipartite graph. Whether it is a complete bipartite, let's check it. With respect to the each color, I have labeled it, and blue color vertices are placed in a one set, yellow color vertices are placed in another set. Now, whether A is connected with B? Yes. A is connected with C? Yes. A is connected with E? Yes. Whether A is connected with H? No. As A is not connected with H, due to which this is not a complete bipartite graph. It means all these statements are incorrect. Hence, option D is correct. The statement, the reason 1 and 2 all are not correct. Next question we have, which of the following statements are true? There is a simple path between every pair of distinct vertices of the connected directed graph. Second is, a directed graph is weakly connected if there is a path between every pair of vertices in the underlying directed graph. Let's suppose an example, whether there exists a simple path between every pair of vertices. Take A and B. Whether there is a path from A to B? Yes. Whether there is a path from B to A? No. It means P statement is incorrect. What about the second one? Weakly connected. If there is a path between every pair of vertices in the underlying undirected graph, as it is a definition of a weakly connected, and that is the correct one. So only Q option is correct. Next, which of these adjacency matrix represents the simple graph? Adjacency matrix is between vertices to the vertices. Now, if it is a simple graph, it means no multiple edges and no self loop. As nothing is mentioned, it means we treat it as the undirected graph. So, if it is undirected, no multiple edges, no self loop. What is the restriction on the matrices we have? Undirected graph means adjacency matrix must be symmetric. No self loop means diagonal entries are 0. No multiple edges means entries are only 0 or 1. It cannot be a 2 or a 3. So with this, we can directly discard the option D because here we have 2. If any diagonal entry is 1, discard that. Only one option is left, that is B. Check it whether this is a symmetric matrix. No. Even it is not a symmetric matrix. So none of the option is correct in this case. In case we have 1 here, we can say that B is correct option. Next question is, which of the following statement is wrong? A complete bipartite graph Km, n has total edges as m into n. Second is, it is a count of vertices. Third is, star graph is a special type of bipartite graph. And the last is, a complete bipartite graph is regular if m is equal to n. Let's check it. In a complete bipartite graph, let's suppose K2, 3. It means 2 vertices in a one set, 3 vertices in another set. These 2 vertices are connected with all the vertices of the other set. The total number of edges in this case is 1, 2, 3, 4, 5, 6. Total number of vertices, that is 5. Here we have 2 vertices and here 3 vertices. For this case, number of edges is equal to 6. That is the product of these two ones. It means first statement is correct, but second statement is incorrect. As per the statement, we need to find the wrong statement. It means B is the correct option. Moreover, C and D are both are the correct option. Complete bipartite graph is a regular only in a one case when m is equal to n. For example, K3, 3. 3 vertices in a one set, 3 vertices in another set. This vertex is connected with all these 3 vertices, so its degree is 3. Even its degree is 3, its even degree 3. Same for this one. So degree of each vertex is same, that is called as a regular graph. That is only possible when m is equal to n. Next question is, if G is a graph with 21 edges, it means total count of edges in the graph is equal to 21. 3 vertices of degree 4 and all other vertices of degree 3. Then total number of vertices in a graph G is. So total number of vertices in a graph, let's suppose n. Now 3 vertices are there of degree 4 and other vertices of degree 3. Other vertices are n minus 3 because total vertices we have taken n. It means total degree of the graph, that is equal to 2 times of number of edges by the handshaking theorem. Total degree is equal to 3 vertices of the 4 degree plus remaining vertices, that is n minus 3 of the degree 3. Total number of edges are 21. This is equal to 42. Here it is at 12. Simplify this. This is 3 times of n minus 3 is equal to 42 minus 12, that is equal to 30. From here, n minus 3 is equal to 30 by 3, that is equal to 10. So n is equal to 30. Hence, option D is correct. Next, the number of 0 in an adjacency matrix of the following graph. So first we will construct the adjacency matrix. Adjacency matrix defines the relation between the vertices, 2 vertices. So the adjacency matrix of this graph is this. As per this, we have taken the ordering of the vertices A, B, C, D and same order on the column wise. A is connected with B and C, hence the entries are 1. B is connected with A and C, corresponding to A and C, the entry is 1. C is connected with A, B, D. A, B, D. D is only connected with C. So rest of the entries are 0. Now as per the question, we need to count the number of zeros in the adjacency matrix. So total zeros here we have 8. Next is the number of edges in a complete bipartite graph K3, 5 is what? So in this case, total vertices are 3 plus 5, that is 8. So this is the count of vertices, but we need the count of edges, that is always product of these two one, that is 3 into 5, 50. Otherwise, you can construct this graph and count the number of edges. Which of the following is true? A finite connected graph is called a linear if and only if each vertex has even degree. Eulerian means if it is a graph that contains Euler circuit. Now, Euler circuit means we need to cover each and every edge exactly once by writing a circuit. For example, let's take C4. Does this graph has a Euler circuit? Yes, because we can cover each and every edge exactly one, or we can say that we can reconstruct this graph without lifting pen and there is a no repetition of the edges. Now in this case, what is the degree of each vertex? That is 2. It means P statement is correct. So remember that this is the correct result. A graph is called Arelian if it has Euler circuit, and that is only possible when the degree of each vertex is even. On the basis of same, we have another result for the Euler path. It says that if in a graph exactly two vertices of odd degree, then it contains an Euler path. The next statement is a graph is called as a k-regular if there exists a vertex of a degree k. That is completely incorrect because regular graph means degree of each vertex is k, not for only one single vertex. So P statement is true, but Q statement is false.